Do you have data that you want to make sense of? Maybe you want to make predictions. Then you have come to the right place. So machine learning allows us to cluster data, derive insights, and make predictions. And it isn't just for PhDs and tech giants. In this course, you will get hands-on practice using powerful libraries and tools like Pandas, scikit-learn, XGBoost, and Jupyter. So we'll introduce the algorithms, show how to use these algorithms, and then let you try them out. We'll explore clustering, principal component analysis, and making predictions with both classification and regression. Now you get to learn these algorithms with me. Let's get going. Before embarking on this journey, there is a few prerequisites that will help maximize your learning experience. First, a foundational understanding of Python is important. While you don't need to be an expert, familiarity with basic programming constructs like variables, loops, and functions is really important for this course. Second, experience with Jupyter Notebooks is really beneficial. Jupyter provides a web-based interactive computing platform that enables you to write code, visualize data, and share insights in a single document. It's invaluable for data science and machine learning projects. Lastly, a basic grasp of statistics and linear algebra will aid your comprehension of how machine learning algorithms work under the hood. Understanding concepts like mean, standard deviation, matrix multiplication will equip you with the skills you need to grasp complex machine learning concepts. With these skills in your arsenal, you are ready to dive into the world of machine learning algorithms and solve real-world problems. In this video, we are going to talk about clustering. Specifically, we are going to talk about k-means clustering. And k-means clustering is what we call an unsupervised machine learning algorithm to make clusters from data. The unsupervised portion means that we are going to feed data in. We are not going to provide any labels, and the algorithms based on the data that we passed in will do some processing. In this case, it will give us cluster labels. There are other machine learning algorithms that are unsupervised. We will look at another one called PCA. PCA is also unsupervised. That means it doesn't have labels that come in with it. It just has the data, and PCA will do dimension reduction. So the algorithm for k-means clustering is as followed. We are going to choose a k where k is the number of clusters, and then what happens is the algorithm will choose 3 points from the data that we passed in, and it will go through and label the points that are closest to each of these clusters. It calls the clusters centroids. After it's gone through labeling those, it will recenter the centroids. It will go through everything that's labeled in cluster 1. It will move the centroid to the middle of that cluster. Everything for cluster 2, same thing. Same thing will move the centroid. And then after it's moved the centroid, it repeats the algorithm, meaning it goes and finds the points that are closest to each centroid. And it does that, and eventually the centroids come to common state. I'll show you an example right here. So here we are using the scikit-learn library, and it has clustering in it. Let me walk through the code. At the top, we have our imports. We are going to be using k-means library. We are also importing the datasets library to load the iris dataset, and we are going to be using matplotlib to do some plotting. We will load the iris dataset and make a variable called dataset. And then I'm going to make a variable called x. Capital X is a common convention that you will see used throughout the scikit-learn library. In linear algebra, a capital variable is used to describe a matrix or a two-dimensional group of data with rows and columns. And that's a common convention that you will see in scikit-learn. When we are passing our data into scikit-learn, it's generally in two dimensions, rows and columns. So each row represents a sample, and then you can have columns of features that describe what it is in the data. You can also have a Y dataset. Y is used for supervised learning. In this case, the dataset that we have, which is the iris dataset, is a classic dataset for machine learning. It's got 150 rows. Each row represents a different flower from the iris family. And there are three different types of flowers: Virginica, Setosa, and versicolor. And there are a few features in the X variable that describe the shape and dimensions of the petals and the sepals of each of these 150 flowers. The next thing I'm going to do is I'm going to make a list of my centroids, and then I'm just going to loop over 10 times. I'm going to run this algorithm I just talked about 10 times in this little for loop down here. So you can see at the top, I'm making a model and I'm saying I want to have three clusters in here, and I'm initializing the k-means algorithm. Then I'm going to call model.fit. One of the nice things about scikit-learn, and we'll be using it throughout this course, is that it has a consistent interface. So once you learn that interface, it's really easy to use. Unsupervised learning algorithms will use fit, and you will just pass in X along with that. For supervised learning algorithms, which we will see later, you will call fit with both X and Y. The next thing we are going to do is we are going to predict our labels. And because this is a prediction algorithm, it can make predictions. We are going to pass in our X, and it will give us out a label for each row. Again, scikit-learn uses the same interface all over the place. We will see when we do classification of regression models, they will also have a predict method. This is really nice because when you understand the basics of scikit-learn, it uses a consistent interface all over the place, and it will make your life a lot easier. So the next line, we are going to create a matplotlib figure and axis, and then I'm going to plot on top of that a scatter plot. I'll also pull out the clusters centers. You can see that I'm saying model.cluster underscore centers underscore. One thing to note in scikit-learn is that attributes ending in underscore are learned when we call fit. So when we call fit up above, it determined where those cluster centers are. I'm also going to plot those as a star on my plot. And I'm going to make a little title for my plot. It's called iteration, what iteration I'm on. And then I'm also going to if my round is greater than 0, I'm going to plot the previous centroids, and then at the end of my for loop, I'll just keep track of my centroids. So what this is going to show us is that as we move through the algorithm, the centroids will move along as well. And then at the end, outside of the for loop, I will just plot the original data so you can see that compared to what's going on here. Let's run this. Okay, so it looks like it just ran, and here is our plots. We should have a series of plots. Here is the first iteration. You can see that I have 3 stars here, and we have green labels, we have purple labels, and then we have yellow labels. So this is the first iteration. After we have done this iteration, what's going to happen is the star will move. It will center inside of the labels, and so we can see that in the next iteration, we can see that the stars have migrated a little bit, and we can also see that the boundaries between those different clusters has moved as well. Here is another iteration. You can see that we are just slowly shifting those centroids a little bit, and I'll just scroll down to the bottom here. You can run this on your own and look at what's happening at the individual levels. But here is the original data, and in the original data, this is colored by the target. Note that I did not include the target in my data that I passed into the algorithm. I just passed in the dimensions, but here I have the dimensions. And I'm labeling these by the type of iris that it is. Remember, there is 3 different types here. And you can see on the upper left, there is one type. In the middle, we have that green type, and there is some overlap there with the yellow type on the right. However, if you look up above here, our clustering algorithm did a decent job. It's not perfect, but it did seem to be doing a decent job getting the upper left group classified. And it's not able to do the overlapping that we see at the bottom, but it does a decent job. Okay. And this section, I gave you an introduction to the k-means clustering algorithm. This is an unsupervised algorithm that you can pass in data in. You can tell how many clusters you want, and it will return labels for pieces of data that are in the same cluster.